Okay, whoops, sorry about that. So now we're looking at secant segments, two of them together, and how we can use that to find the length. Remember, the key here is the whole segment times the outside of one equals the whole segment times the outside of the other. So as we do this first one, we got to find the value of the variable and then the length. We need the whole thing times the outside. Now be careful. The whole thing here, whole times the outside, the whole thing is x plus 8. The outside is just the 8. Remember I said you would use it twice. For the other one, whole times the outside, the whole thing here is 16. The outside is just 7. Okay? So then here on the left we have to do the distributive property. Multiplication is commutative. The order doesn't matter. That means we can distribute in backwards. We'll get the same thing. 8x plus 64 equals 16 times 7. We got to get our calculators out because that is a tough one. 16 times 7 is 112. Okay, then we will subtract 64 from both sides. When we do that, 8x equals 48. We're doing great. Yeah. 8x equals 48. That means x equals 6. So x equals 6 here. We found the value of the variable. Each secant segment. Now when we talk about that, we are talking about we want the whole segment. So the whole GE here is x plus 8. It's 14. 6 plus 8 is 14. We already figured out the whole DE. All of DE is 16. 9 plus 7. Alright, we figured that out when we started the problem. Carried it all the way across. 9 plus 7 gave us 16. Okay? Let's do the other one real quick. Same thing. We got the whole thing times the outside. Now the thing we have to keep in mind here is that z is that inside piece. The whole thing then is z plus 13. So we got the whole times the outside. The whole thing was z plus 13. We just talked about that. The outside is just the 13. That equals, from the other secant segment, the whole thing is 30 plus 9, 39. The outside, that's just 9. So the whole thing, 30 plus 9, 39. The outside, just 9. Okay, once again, distributive property, 13 times z, 13 times 13. 13z plus 169. We should know that one. That's a perfect square. It's a good one for you to know. Then that equals 39 times 9. 39 times 10, that's 390. 39 times 9 is 1 less 39. It's 351. Then subtract 169 from both sides, and 13z is equal to 182. 13z equals 182, which means that z equals 14. That's great. Now we have to find the whole secant segment. Well, JG up here equals z plus 13 equals 14 plus 13, which is 27. On the other hand, we have 30 times, excuse me, not 30 times 9, 39. Right? Because 30 for the inside, 9 for the outside, so the whole LK is 39. So there are secant and secant segments. Secant. Right? We have two secant segments. They intersect outside the circle. whole times the outside equals whole times the outside. So those two things are kind of new. Chord, secant, secant. If you flip your sheet over, we get to our next one. And the next one is one that hopefully you remember from earlier in the chapter. Okay? Hopefully you remember talking about tangents. Remember, if two segments are tangent to the same circle from the same point, then they are the same length. Okay? Here's what we're saying there. Two segments tangent to the same circle from the same point, and those are the same length. Right here, AB, this segment is tangent to the circle at point B. This segment is tangent to the circle from point C. They are tangent to the same circle from the same point, so they are the same length. AB is congruent to AC. You can even draw that. There it is. They are congruent. Here's the same point. Of course, this would be the same circle. It's the only circle up here. And of course, the same length we can mark with our congruent marks. Same circle, same point, same length. We use that to solve. Right? And let's get this out of here because it's getting in our business. Okay? We just have to find the value of the variable and the length of the tangent segment. We've done this. You've done this. You've done a good job with this. Right here, these two things, GH and HK, are both tangent to the same circle from the same point. So 4 plus 2a equals 5a minus 32. And we'll show a few more steps with this one. You can subtract 2a from both sides. All your variables on the same side. 4 equals 3a minus 32. Add 32 to both sides. 36 equals 3a. When we divide both sides by 3, a equals 12. Okay, so a equals 12. That's great. We've answered the first half of the question. To answer the second half of the question, we have to find the length of each tangent segment. They're the same, right? Here's what we know. We know that these two things are congruent. That means 4 plus 2 times a, 12. 4 plus 24, or a total of 28, is the length of GH, and it's also the length of HK. The length of each segment is 28. Do the same thing over here. We got two tangent segments. They are tangent to circle Q from point R. It means that n plus 3 equals 2n minus 1. Subtract n from both sides. 3 equals 2n, take away 1n, that just leaves us with n minus 1. And we probably don't even need to show this last step, you guys are so good at it, but n equals 4. N equals 4, we have answered the first half of the question. The second half says find the length of each tangent segment. Well, if n equals 4, n plus 3 here, 4 plus 3 tells us that the tangent segment is 7. They're congruent, so if this one's 7, then you can bet the other one is 2. Tangent segments are one of the easier ones, but we threw it in because we've done chord, secant, secant, and now tangent, tangent. The latter two of those, or the last two that we just talked about, secant, secant, and tangent, tangent, we're going to put together for our third and final, or excuse me, our fourth and final piece here. Maybe, come on. Away. Okay. Last piece of what we're talking about today is secant and tangent. If a secant and tangent intersect in the exterior, then the product of the lengths of the secant, the whole times the outside, is equal to the tangent segment squared. Whole times outside equals tangent segment squared. So here's the whole thing. Here's the outside piece. Whole times outside. That equals our tangent segment squared. Okay, not too difficult. I think we're going to be okay. The whole times the outside equals the tangent segment squared. That should make sense because the whole and the outside for a tangent are the same. If we got the same thing multiplied by itself, it is squared. Okay? We're going to do two problems from here. They're not so bad. I think we'll be okay. Find the value of the given variable. You have your secant segment. We got a whole part and we got an outside part. Whole times the outside. That equals the tangent squared. And the tangent segment here is k, or x. So x squared, so it would be kl, and the actual length is x. The whole segment is 15 plus 5, that's 20. The outside part is only 5, so 20 times 5, that's 100. 100 equals x squared. You guys are pros. You know that the square root of 100 is 10. X equals 10. Great. So the other one. The other side, we got our secant segment, df. The whole thing is df. The outside is 7, de. Whole times the outside, that equals the tangent segment squared. The whole thing here is y plus 7. The outside is just 7. The tangent is 10. 10 squared. Distribute our 7. 7 times y, 7 times 7, 7y plus 49. That equals 100. Subtracting 49 from both sides gives us that 7y equals 51. Dividing both sides by 7. This is a decimal. Decimals happen, right? We're not afraid of them or anything. We know they happen. In this case, the answer then is 7.29. Y is 7.29. Okay, I hope you've jotted all of this down and taken good notes. You have a worksheet to do today. It's a yellow worksheet. There's a couple problems that are scribbled out. I would like you to do all of the rest of them. Okay? Figure out what picture you're looking at. Which one of these is it? Is it chord, chord? Is it secant, secant? Is it tangent, tangent? Or is it secant, tangent? Figure it out, set it up. Some things to keep in mind. Whole thing versus outside. Whole times outside. In a tangent, you have to square it. In a chord, we multiply using the same pieces of the segment. Right? If we got a segment that's got two parts, we take one part times the other part equals the third part times the fourth part. I think you're going to do just fine. Refer to your notes, and they will hopefully help you. We'll go over this on Monday. So do good work.